So the second part of our lesson for 3.6 is going to be looking at the rational inequalities. So once again, I have a couple examples of what they look like. We should be somewhat familiar with how those work and how they look. So the procedures for solving this kind of going to be similar to the polynomials, at least kind of the idea of how we're going to test subintervals. So what we want to do is first find the x-intercept of the graph by setting the numerator equal to 0 and solving. Note, this value may or may not be part of the solution. It's going to depend upon the inequality. So these, the x-intercepts would be included because of the equal to part of the inequality. Down here on our first example, it will not be part of our solution set. Then the other key point we're going to look for is the excluded domain value by setting the denominator equal to 0. Now, it's an excluded value, therefore, it can never be part of the solution. Okay, so it's excluded. You can't even plug it in because if you do, you get undefined. So that one will always be excluded from our solution set. So then step 3 will be create your number line using the values from step 1 and 2, and then test the values in each subinterval. So let's look at our first example. Once again, it has a picture. They won't all have pictures. It just kind of helps illustrate the concept a little bit better. So on this first one, if you wanted to find the x-intercept, you take the numerator, set that equal to 0, solve. So we get x equals 0. So that's where our x-intercept is going to be, and you can see it right there, right? Okay. And then if we want to find the excluded value, we'll find the vertical asymptote, basically. So you take the denominator, set that equal to 0, and solve, and you get x equals -6. And so you can see that that's right here. So see, that's excluded. So if you plug it in, it's undefined. So it's impossible for that to be part of my solution set. So we'll put -6 right there. I'll put 0 right here. They are both, neither one of those can be part of my solution set. The x-intercept, now, if we had this here all of a sudden, then yeah, we'd say, okay, 0 can be included. But since we don't have the equals to part, we can't even look at that. All right. So we're going to go ahead and test some points. So we'll test like, -7, -1, +1. That looks good. Okay, so if we plug in -7, we'll get 3 times -7. Let me give myself a little bit more room. I'll put that there in a second. Okay, so we'll have 3 times -7 over -7 plus 6, and that needs to be less than 0. So see, we're testing it right now. Okay, so let's see. That'll give us -21 on top. That'll give us -1 on top. Less than 0, double negatives becomes positive 21 is less than 0. 21 is not, positive 21 is not less than 0, so that is false. So we are not going to shade that part of the number line. Now we can try -1. So let's see, 3 times -1 over -1 plus 6. I'm just plugging it right back in here to test it. So on top, let's see, we get -3 over +5. So that's a negative ratio. I don't have double negative, so that's a negative ratio. And so that comes back true. Yeah, a negative ratio is less than 0. So that comes back true. So we're going to shade between. Now remember, -6 cannot be included because it's the restricted value, first of all. And then 0 is not included because that would make it equal to, it would make our expression 0, which 0 would not be less than 0, so that's not included. But everything between those numbers is included. And then we'll try +1. It's possible that it is. Let's see. So let's see, 3 times 1. Let's see, over 1 plus 6. Is that less than 0? So we get 3 over 7 is less than 0. Oh, no, that's not going to work. Positive ratio is not less than 0, so that's going to be false. So our solution set is just between -6 and 0. That's our solution set right there. And if you look at the picture, yeah, that seems about right. So for the x values that you plug in and the results come back as being less than 0 is this little red line right here. All right, let's try a couple more. Okay, here's another one. So we've got x minus 4 over x plus 3 is greater than 0. So the first thing you want to do is find the x-intercept. So you take x minus 4, set that equal to 0, and solve. So we get 4 right there. Then if we want the excluded value, basically, I just label it as vertical asymptote. X plus 3, set that equal to 0, and solve. We'll get x equals negative 3. Okay. Now, that's definitely excluded because that's the vertical asymptote. And then the x-intercept is going to be excluded too because if you plug it in, it'll come back false. 0 is not greater than 0. So both of those, neither one of those will be included. So you can put open circles on them now if you'd like. And so we'll test like negative 4. 0 is always a good one to test. And then 5. So let's see, if we plug in negative 4, let's see, we'll get negative 4 minus 4 over negative 4 plus 3. Is that greater than 0? And so we're going to end up with negative 8 over negative 1 greater than 0. Double negatives becomes positive. And so positive 8, yeah, that is greater than 0, so that will be true. So we'll go ahead and shade there. So that's one of my intervals that will work. And so now we'll try 0. 0 minus 4 over 0 plus 3 greater than 0. Asking ourselves that. So we get negative 4 over 3 is greater than 0, so we have a negative ratio. Negative ratios are not larger than 0, so that will come back false. Okay, and so now we'll try 5. So let's see, 5 minus 4 over 5 plus 3, is that greater than 0? So we're going to get 1 over 8 is greater than 0. Positive ratio greater than 0. That is true. So then we're going to go ahead and shade here to positive infinity. So one of our intervals goes from negative infinity to negative 3. That's going to be that first one right here. And then we have another interval right here from 4 to positive infinity right there. So make sure you look at the number line, make sure you're lining up your values correctly. Don't get confused by the tested ones. Okay, I believe I have one left for us. It's going to take a little trickery with our algebra here, but we should have those skills. So the issue we have with number 55 is that it's not the inequality, one side needs to be 0. So the first thing you want to do is we're going to subtract 2 from both sides. So we end up with x plus 1 over x plus 3 minus, I'm going to put this as 2 over 1, and you'll see why in just a second. Okay, so what I'm going to have to do here, in order to solve this, I really need this as one fraction. So right now I have 2 parts, and it makes it a little bit more challenging. So we want to bring this together as a single fraction. So I need an LCD of x plus 3. So what I'm going to do is I'm going to tack on an x plus 3 to both the top and the bottom of my 2 that I had moved over to the left side. And so now what I have is I have x plus 1 minus 2 times x plus 3 all over that common denominator of x plus 3 right there. So then what we're going to do, I could have distributed the minus 2 on the previous step, but I like to kind of break it into 2 steps, make sure we don't get confused. So let's see what we have here. We're going to have x plus 1 minus 2x minus 6 all over x plus 3. And then we're just going to clean up the top. So let's see, that'll give us negative x minus 5 all over x plus 3. And by the way, I kind of dropped my inequality along the way. Bring that, oops, that should be 0. Bring that back. So let's see, 0, 0, 0. There we go. Okay, so now I need to find those 2 key points, the x-intercept. And see, I'm just going to do this down here. So my x-intercept, you just take the numerator, set that equal to 0 and solve. So what I can do here, make life a little easier, just add x to both sides. So we'll have -5 equals x. So that's my x-intercept. Now, this time, since the inequality, we have the equals to part, so if I plug in -5, it would cause it to be 0, which would come back as a true statement. So this time I actually will get to include that. Now for my vertical asymptote, I take the denominator, set that equal to 0 and solve, which should be x equals -3. Now that one will never be included, so we will not include that. So on my number line, I'm going to put -5 right here, put my -3 right here. -5 in this particular case will be included, and vertical asymptote's never included. So then I need to come up with some points to test. So we can test like -6, -4, and 0 would probably be an easy one to test. Okay, you can test it in the original equation, but I wouldn't suggest doing that just because we're probably going to get a lot of fractions back, and it might be hard to determine if it's less than or equal to 2 or not. I mean, if you have a calculator, it probably won't be that big of a deal, but it'll probably be a little bit easier to work with this one right here. So I'm going to plug it into the final one after we did our manipulations. So if I plug in -6, we're going to get -6 minus 5 over -6 plus 3. Is that less than or equal to 0? So the double negatives will make that +6. 6 minus 5 is a 1, so I get a 1 on top. And then on the bottom, -6 plus 3 is -3. So I have a negative ratio. A negative ratio would be less than or equal to 0. So this first one's going to be true. So this first one comes back true. So we'll shade to -infinity right there. Now let's try -4. So let's see. I'll have -4. Let's see, -5 all over -4 plus 3. Is that less than or equal to 0? So on top, let's see, double negatives, that would become +4 minus 5 is -1. On bottom, -4 plus 3 is -1. And so those double negatives are going to cancel out and become +1. +1 is not less than or equal to 0. That's a false statement. So we will not be including this part of the number line. And then for our last one, we'll try 0. So -0 minus 5 over 0 plus 3. Is that less than or equal to 0? So -0, that's kind of silly, just 0 minus 5, so that's -5 on top. On bottom, 0 plus 3 is 3. So I have a negative ratio. Yep, negative ratio would be less than or equal to 0, so that one's going to come back as true. So we'll go ahead and shade off towards infinity right there. So last thing we need to do is transform that number line into interval notation. So -infinity to -5, and we'll go ahead and include -5. Okay, union. Then we're going to go from, let's see, -3 to +infinity. And there we go. All right, I hope that's helpful. If you have any questions, feel free to send me an email.